It's recording. Sorry. Okay, this is section 7, topic 5. And we are on page 147. 147. And this is called graphing rational functions. Alright, so we know how to graph linear functions. We know how to graph quadratic functions. We know how to graph lots of different kinds of functions, but to graph rational functions, there's a lot to know, okay? So we're going to have multiple steps with a lot of stuff written down for graphing rational functions. So step 1 is find the x-intercepts. Find the x-intercepts. Remember, that's going to be where the graph crosses the x-axis of the function. To do so, comma, substitute a 0 in for y and solve for x. Period. Plot any x-intercepts on the x-axis. Step 2. Find the y-intercepts. Of the function. Period. To do so, comma, substitute a 0 in for x and solve for y. Plot any y-intercepts on the y-axis. Step 3. find any vertical asymptotes. Have we talked about asymptotes before? Thought we did. Asymptotes is kind of like, it's where a line that your graph approaches, but it doesn't touch it. Okay, it kind of hugs the line. So I'll just show you this example. This is a rational function that has been graphed. These dotted lines are not part of the graph. They are asymptotes. Okay, so an asymptote, a horizontal asymptote, and a vertical asymptote. So this graph is approaching this horizontal asymptote, but it will never touch it. It gets close, 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 but that's it. And over here, it approaches the vertical asymptote, and it just hugs it all the way down. It just gets closer and closer and closer, but it never touches the asymptote. And then the same thing up here, okay? So that's what an asymptote is. So the first thing we're doing in step 3 is finding vertical asymptotes. Remember, vertical is up and down, and then horizontal asymptotes will be left and right, okay? Graphs of rational functions can have an unlimited number of vertical asymptotes. To find vertical asymptotes, make sure the numerator and denominator are completely factored. Cancel any common factors. So when we were solving rational functions, we didn't have to factor the numerator, only the denominator, right? And then we would multiply every term by the least common denominator and cancel the like terms or the like factors. But when you're graphing, you have to factor the numerator and the denominator. And then if you want to know where your vertical asymptotes are, then you cancel out any common factors. All right? If no factors can be canceled, then the vertical asymptote has the same equation as the restriction. This is referred to as non-removable discontinuity. So last class when we, remember when we talked about extraneous solutions? Right, and if you got a solution and you substituted it back into the problem, if it turns your denominator into a 0, then that's called extraneous, right? Well, what we didn't talk about is restrictions. And sometimes a question will say, list any restrictions. And restrictions are the numbers that would turn your denominator into 0. So if I had x minus 3, what would I substitute in for x that would make it a 0? 3. So we would call 3 a restriction, okay? If I had x plus 2, what would x have to be in order to make it a 0? Negative 2. So we would say negative 2 is a restriction. Restrictions are things that x cannot be, because if they were, your denominator would be a 0, okay? The way that the questions that we did said, is your solution extraneous? And you know, if you plug that number in, it's yes or no. So restrictions are just looking ahead of time and saying, if you get these numbers as your answer, they're restrictions, so that's going to be an extraneous solution. We'll talk about it more, obviously, when we start graphing, but I just wanted you to know what it meant when it said, if no factors can be canceled, then the vertical asymptote has the same equation as the restriction. All right? Last thing in this step is sketch any / all vertical asymptotes. I did a whole page. I think I still got a whole other page to go. Anybody still writing? Y'all know not to come to school on Monday, right? Currently talking to 4th period only. I'm videoing this. All right, step 4, page 147. Determine if you have a horizontal asymptote. Put a little star here. The graph of a rational function what's that? My page number's wrong? 148. Thank you. No, usually don't tell me when I'm wrong on the video, and I don't notice it until if a class watches it. I haven't figured out how to go back and edit the videos yet. The graph of a rational function can have no more than one horizontal asymptote. Remember the vertical, you could have an unlimited number of vertical asymptotes. But for horizontal, no more than one. the degree of the numerator remember, numerator is the top part of the fraction, is less than the degree of the denominator then the graph has a horizontal asymptote at y equals 0. So horizontal means it's going to cross the y-axis, okay? And if it's crossing the y-axis at 0, that's going to be the same line as the actual x-axis is, okay? It's not above the x-axis, it's not below the x-axis, it's on the same line as the x-axis. So that's y equals 0. X equals 0 would cross the x-axis at 0. Y equals 0 is like this. So I'm going to put that in my notes. Same as the x-axis. Sketch it. Now you're only going to have that horizontal asymptote at y equals 0 if the degree of the numerator is less than the degree of the denominator. That's the only time that's where your asymptote's going to be. Okay? If the degree of the numerator is greater than the degree of the denominator, if the degree of the numerator is greater than the degree of the denominator, then the graph has no horizontal asymptote. And you're going to have that a lot. Usually, like all those problems that we divided, the degree in the numerator was always greater than the degree of the denominator. So whenever that's the case, you just don't have a horizontal asymptote. Nothing needs to be sketched in this case, obviously. If you don't have a horizontal asymptote, check to see if you have an oblique slash slant. Sometimes you'll hear it called oblique asymptote. Sometimes you'll hear it called a slant asymptote. Same thing. Check to see if you have an oblique slash slant asymptote. And that will be the next step, step 5. But I still have one more thing to look for horizontal asymptotes, okay? But if you don't have a horizontal asymptote at all, you might have an oblique asymptote. But there's one other thing to look for horizontal. So we said if the numerator is less than the denominator, talking about degrees, we said if the numerator is greater than the degrees of the denominator. And now we're going to say, okay, well, what if the degrees in the numerator is equal to the degrees of the denominator? Then what? So if the degree of the numerator and y'all know these notes are no good if you don't go back and read them. When you're trying to do your work, if you just try to remember it all and don't go back and follow the steps in your notes, there's no point in us taking these notes. You have them to help you. Is equal to the degree of the denominator comma, then the graph has a horizontal asymptote. When I finish this. At y equals a divided by b, comma, where a is the numerator's leading coefficient and b is the denominator's leading coefficient. Sketch it. Pause, please. I think so. It was, yeah, it was pretty fast.
No, I don't need you.
No.
I don't know what you're doing.
We're graphing some rational functions. You need me to schedule the thing with you?
Probably, but I don't know. My schedule is just about.
Okay. I was going to say, I was thinking maybe this day.
Tuesday.
Oh, yeah, not that day.
Tuesday's pretty full.
Oh, it's pretty full?
Yeah. Maybe Wednesday.
Wednesday's
Wednesday's 4 people say.
Like looking over here at like
this class will probably be reviewing. Hold on, guys.
They don't matter.
I don't know. Let me look. I'll look. Can I look here?
Yeah.
Okay.
We can talk.
Okay. This is pretty boring. We're writing down a bunch of steps right now.
Steps.
Steps for graphing.
draw a perfect circle.
No, I cannot teach you how to do that. You have to go.
I heard he can.
You have to go to college.
You can teach us how to draw perfect circles.
No, I heard Mr. Brown can.
I'm pretty good.
Brown does the perfect.
The mostest perfect circle there is.
It's hard to do with a marker. It's easier to do with chalk.
Alright, back to where we were. Because we have stuff to do. Now my last step, I'm gonna just do it on the next page. This is the last step. Is everybody finished with this one? Almost?
Are you recording yourself?
Yeah. So you're on the recording. You wanna go watch the playback. We all good? Alright, 149. This is step 5. So this was that other kind of asymptote I was talking about. The slant one. Also called oblique. Does that color show up okay? Switch. Okay, determine if you have an oblique/slant asymptote.
Do you know who watches these?
No one? I mean, they're supposed to if they're absent.
No, I mean, you don't, I mean, it doesn't show up like on a
Oh.
list, like
No.
Big Dog 18 watch.
No, I attach it to YouTube. And so on YouTube, because Edmodo won't let me upload a file this large,
Right.
and so I have to attach it to YouTube. So YouTube will show me how many times it's been viewed, but it won't show me who's viewed it.
How many is your biggest? Anything went viral?
No, I'm at like 22. Yeah.
2,200. What's going on?
Yeah. But they told me if I get more followers that I could get paid. I've got like, I think I have 7
I
now.
think it's on how you title it.
Yeah, I don't know, I have like 7.
You
So
have
it's
to-
one more this year than I had.
There's a rule with YouTube, you have to earn like 300,000 subscribers in your first month in order to be monetized.
300,000? They told me 1,000. My last class told me
Something like-
1,000.
Yeah, it was like
Change your last name to Paul.
Paul? Like RuPaul?
Not RuPaul.
Who?
Yeah.
Renee, her first name's Renee.
Renee
You
Paul?
need to change your last name to
Like
Russo.
Logan Paul.
Logan.
Jake Paul.
Who's that?
Oh, it's
Ohio fried chicken.
It's every day, bro, with
I don't know what you're talking about. I've never heard that in my life.
Who's that?
It's the pinnacle of art.
Oh, really?
I'm just like,
This only occurs in rational functions. We're almost finished with this part anyway. When the degree of the numerator they're still not used to that.
Me either.
6 years.
What does
6
that mean,
years.
degree of the numerator? Just throwing it out there, because I don't know.
That's the number.
The number what? Nobody knows what that means?
Yes, they do.
The number on top of the fraction?
No, degree. Hold on.
The number of exponents.
Hold on.
That's what he said.
Hold on. Let me give you an example. In this problem, what is the degree? Can y'all see this? What's the degree here? 2. Because of this 2?
no, it's the exponent.
Oh, the exponent. Okay. What's the degree here?
3.
3. You've been wanting to know when we were going to do synthetic division to
And you
find
did it?
factors. We finally I was just waiting for you to come in that day. We did it.
Did y'all like synthetic division?
No.
What? It's so easy.
Remember what happened that day?
Hey kids, what's the degree here?
4.
See, they know what degree is.
Okay, so you know what degree is, and what did she just say in that other statement? The degree of the numerator, and the numerator is the top of the fraction? Okay. I just asked.
Can y'all tell them what the end behavior is? I bet you can. And this one, what's end behavior? What's up and up? What's the y-intercept? -1. What else can we know? How many solutions can we have? Roots, zeros, 4. Do they all have to be real? No. What's the end behavior on this one? Y'all better get right.
Up and down. All right, no. Down, down.
Down and up. Up because it's positive. It's going to end on a positive note, right? What's the y-intercept? -6. What else? How many solutions, roots, zeros are we going to have? 3. See, they know stuff.
I know.
They know stuff.
Awesome.
What else you want to
They
know?
know, they know, they know.
They know they're tired of taking notes on how to graph a rational function.
Does that song have any other words?
I don't know.
They know, they know, they know.
I guess they know. The other words, I don't know.
I guess I don't know that one either.
Nobody knows.
They know.
They know, they know, they know.
Can you sing it better? Who sings that?
That's the name of the song, they know.
Is that
The
it?
artist.
Who
They know.
sings it?
They know.
Who sings it is the question.
Who sings they know?
Mr. Brown? Drake is the singer?
Does it say anything besides they know? They know, they know, they know. They know, they know.
What do they know?
They know.
They just know.
They just know.
Yeah, like Nike. Just do it. You just do it.
Hey, now that I'm over here, I can see Kid Danger sitting in the
Oh, yeah. He put himself over there.
corner. Nobody could fake
That's what I said. They didn't know what I was talking about.
It's not really like.
See, I might not know who Ohio Fried Chicken guy is, but I know who Baby is.
Everybody knows who
Not
Baby
that
is.
guy.
You know why they know who Baby is?
Why?
Because, what's his name?
Who? Patrick Swayze?
Patrick Swayze. Patrick Swayze was born back then. Oh, this is on the recording.
Okay, yeah. This whole thing is on the
It's gonna
recording.
go viral now.
It is, yeah. Oh, Patrick Swayze. Yeah. I literally have like 2 more sentences and then we're done with these steps, okay? Thank you for visiting. I'll get with you about that other thing.
I love how you said no questions.
I know.
And like your whole video was really good.
I'm going to have to redo the whole thing. Thanks, Mr. Brown. Alright, determine if you have an oblique/slant asymptote. This only occurs in rational functions when the degree of the numerator is just 1 degree greater than the denominator. Just 1 degree greater than the denominator. Then you have an oblique, or you could call it slant asymptote. Okay? If so, because I got to tell you how to find what it is. If so, use long division, which we already know how to do. We did that with the remainder theorem. Use long division to find the quotient. This will give you the equation of the oblique asymptote. So when you do long division, you know how we have what's left at the bottom and we put the degrees in, right? So that's going to be the equation of a line, and which will have a y-intercept and a slope. So that's going to be your oblique asymptote, okay? Be an equation of a line. It won't be horizontal or vertical. That would be a horizontal asymptote or a vertical asymptote. Oh, asymptote. That's how I say it. A-S-Y-M-P. Thank you. And important to note, ignore any possible remainder. So if you do get an oblique asymptote and you have to do long division, the quotient is going to be the equation of your asymptote. It's going to be a line. If you have a remainder, when you do that long division, you just ignore that part. Okay? So it doesn't affect anything when it comes to your oblique asymptote. So that's a lot of stuff, huh? How many what? 14?
I said 15 on the
14, I think.
We're only halfway there.
But the last four, two of them are trig and two are province stats. I kind of group those together. So, everybody cool with this so far?
We're gonna have like 3 more like.
Well, those are serious. But they count them as two separate topics. I kind of just group it all together.
And the dynamic comparison, not the actual comparison, like not the actual play like comparison. They look up like the storyline. Baby is supposed to be like 16, and Touch Series is like 24.
Ew,
Yeah. Isn't that weird?
ain't that weird?
This is not 121.
Oh, it is.
150.
Last year, it was 121. We followed a different order last year. So 150. Thank you.
But like the actors in real life.
Well, here's the thing. I mean, you can start it over there because it will take us more than one page. So if you want to, that's up to you. I just hate starting a problem on the bottom part of one page, but you know what you got to do. It's going to take a lot of space to graph one problem. So, hey guys, I know we kind of got thrown off a little bit, but I need you back here. I'm going to try to get one graphing. You can go. I'm going to try to get one graphing problem done. It might not happen. You don't have homework. Just talking to fourth period right now. It may not apply to the class who's watching this. But I'm going to try to get through one problem. Okay? So, first example. Y equals x squared plus x minus 12 divided by x squared minus 4. Before I start the steps, I'm going to go ahead and factor anything that I can, numerator and denominator, okay? So before I even look at my steps, I'm just going to factor. Factor wherever you can. So y equals, for x squared plus x minus 12, and I'm going to kind of do a little workspace over here. X squared plus x minus 12. Is there a GCF? No. All right, A is 1, B is 1, C is negative 12. I need two numbers that multiply together to give me A times C, so that's negative 12. And add to give me B, which is positive 1. What do you think? Three and 4, both positive? 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. So that's going to be x plus 4 and x minus 3. Do I need to divide and slide?
No.
No. So my numerator is x plus 4 times the quantity of x minus 3. The denominator, that's a quadratic. Is this a special kind of quadratic? Difference of squares. So do I need to do T-chart, divide and slide, and all that mess? No. Can I? Yeah. What would A be? 1. What is B? 0. And C is negative 4. But it's a difference of 2 squares, so I don't need to go through all that. I just need to make 2 sets of parentheses. In a difference of squares, one's going to have a plus in the middle, one's going to have a minus. What's the square root of my first term? What's the square root of my last term? 2. So x plus 2, x minus 2. Oh, and it did not have a GCF. Okay? So this new function is equal to the original function, it's just factored, right? So now I'll start my steps. Anybody have a question so far? So if you go back and look, step 1 said, find the x-intercepts of the function. To do so, substitute a 0 in for y and solve for x. Plot any x-intercepts on the axis. Okay, right now, before I get my graph going, I'm just going to find the points and then we'll come back to them today, okay? Because we probably won't get finished with this. We'll just go ahead and do the steps and then we'll work on the graph later. We'll just find the parts. So, step 1, find any y-intercepts. Remember, y-intercepts is where the graph crosses the y-axis. X-intercepts. Golly, what's wrong with me today? Tell y'all to find my mistakes and I'm just making them left and right. Find any x-intercepts. And to do that, we substitute a 0 in for y, solve for x. I kind of like, at least on the first one, to not rewrite the whole step, but just so when you look back, you know how you got it. Substitute 0 in for y and solve for x. So I have y, I only have one y over here, correct? So I can rewrite that if I want, or I can just say, just look up here, 0 equals, because it said substitute 0 for y, x plus 4 times x minus 3, all over, x plus 2 times x minus 2. Now, we know how to solve rational equations. We just did this last class, and the class before, didn't we? Denominator, can anything be factored? We already did that. So, if we're going to solve a rational equation, which is what we have, we've got a fraction, there's a variable in the denominator, we need to look for the least common denominator. And this is why I just went ahead and factored it from the beginning, because I knew I was going to have to anyway. So, what's my LCD? X plus 2 and x minus 2, fellas. So I'm going to multiply every term by x plus 2 and x minus 2. So the 0 gets multiplied by x plus 2, x minus 2. Yeah. Do I need to distribute all this out? No, because it doesn't matter. When I multiply this times 0, what happens? It's just 0. Don't waste your time multiplying all that out. On the right side, x plus 2 cancels, x minus 2 cancels, so you're just left with x plus 4 and x minus 3. Do I want to distribute all that? No, I'm trying to find the x-intercept, which means I want to solve for x. So don't distribute it all out, because then you're just going to have to factor again, and you're going to end up right back where you were. Okay, so don't distribute. We're going to solve for x. So we have x plus 4 equals 0, and x minus 3 equals 0. So that gives me x is negative 4 because we subtracted 4 from both sides. And x equals positive 3 because we added 3 to both sides. Are either of these extraneous? No. What would my solutions would had to have been to be extraneous? 2 and negative 2. So we would call those restrictions. If I said, what are the restrictions? You would say 2 and negative 2. But for now, -4 and +3 are going to be my x-intercepts. So if we were going to start the graph on the x-axis, we're going to plot a point at -4. We would plot a point at -3. But I'm going to kind of highlight this so that when we go back and graph, it'll be easy to find. Golly.
I think TG should be our math teacher.
She should. Today, anyway. I woke up at 2:30 and never fell back to sleep, so I'm off my game. And that is my excuse. OMG. So we probably had about the same amount of sleep. I have no excuse. I think I have time to get through step 2, which is where we find the y-intercepts. Step 2, guys, let's hold off the side conversations. Just let me finish. Find any y-intercepts. So when you want to know what your y-intercept is, you substitute in a 0 for x, not for y, because that makes your y go away and just leaves you with an x. So if you want to know x, substitute a 0 for y. If you want to know y, substitute a 0 for x, okay? So I'm just going to make a little note, substitute a 0 for x and solve for y. So I am going to rewrite my problem, especially since I can't see it on the screen right now, and there's not just one x like there was just one y. So y equals x squared plus x minus 12, quantity divided by x squared minus 4. Last time when I wanted to find my x-intercept, I substituted a 0 for y. Now I want to find my y-intercept, so everywhere I see an x, I'll substitute in a 0. So y equals 0 squared plus 0 minus 12, quantity divided by 0 squared minus 4. Did I make another mistake? Oh, yes, what? Oh, I could have done that. I could have plugged it in, substituted in the factored form or the standard form. It doesn't matter. Either way. I usually do choose the factored form, but I told y'all I didn't have much sleep last night. But it doesn't matter. Okay, so I have y equals 0 squared is 0 plus 0 minus 12 gives me negative 12. And the denominator, 0 squared is 0. 0 minus 4 is negative 4. Is my y-intercept going to be negative 12 divided by negative 4? No. What would I write? Positive 3. Negative 12 divided by negative 4 is positive 3. So on my y-axis, I just have one y-intercept. So next class, we'll come back in, we'll find all of the other parts, and then we will make our graph. Okay? Yes, we are finished for today. Stay in your seats, please. Oh, actually, I mean, we had time. We have like 14 minutes.